quiz. Be a partner quiz, but it's just going to be 5 problems. But just to get as much practice as we can, I'm going to try to go through both worksheets with you, but going to give you a chance to at least try one each before I go through the problems. Okay, so let's start with number 1. We'll start with worksheet 1. First page, I think it's a little bit easier. So if you look at number 1 here, just think in terms of, well, I know I can represent every trig function as in terms of sine or cosine or a combination of both. So why don't we do that? Just convert everything to be in terms of sine and cosine and see where that takes us. Now, just like your identities that you need will be at the top of the page of your quiz, so you won't have to use your calendar back page formula sheet. I'll present all the formulas you need at the top of your quiz. Okay, so number 1, let's put everything in terms of sine and cosine. Cotangent is cosine over sine. Secant is 1 over cosine. Okay, does everything clean up nicely here? Yes, right. Sines goes away, cosine goes away. All we're left is with 1. Yes, question?
I did it.
I'm sorry?
I did it.
Okay, how did you do it?
I did sine over 1 times 1 over sine over cosine.
That works, yep. Yeah. I just decided to convert cotangent to be cosine over sine, but you went through the tangent route, which is fine. Okay, number 2. Any idea as a first step that we can take for number 2? Okay. Yeah, GCF, right? GCF. When I see 2 terms, I'm thinking, well, maybe there's some common term that is shared between those 2, and we do see a common term, right? And factor out a cosecant squared. Which means the leftover will be inside a set of parentheses. Now, when you factor GCF out, what you're really doing is you're dividing your expressions by that common factor. Okay, so can you say it the whole time? Okay. And everything you see, f and f plus, I think will all be the same function. Change it there. Base it off. You said it. Okay, so once we identified our GCF, we can divide out that GCF from both terms. First term, we're left with what? This 1 minus. Good. All right. The second expression is going to fully remove the cosecant squared. There's still a cosine squared left. Okay, so we're making progress here. 1 minus cosine squared. So ringing a bell here. Yeah. Identity, right? We got an identity that we can apply here. Now, as you're doing these problems, right, every step along the way, you're always taking a peek at the right side, right? Because every step along the way, you're kind of just wanting to know, am I getting any closer, right? Because sometimes you may have 2-3 decisions that you could make, but you're always using the right side to kind of help guide your next step, right? You want to take steps to move towards the right side, and maybe there are other identities or properties you can apply, but you're always choosing the one that is getting you closer to your goal. Okay, good so far. Cosecant squared over sine, cosecant squared times sine squared. Okay, we know that these are reciprocals of each other, so you just call this 1, or if you want to go one step further, that's fine as well. Either way, we have our right side. Try number 3. Number 3 should feel like number 1. You're just putting everything in terms of sine and cosine. Okay, everything in terms of sine and cosine. Everybody good with 3? Okay, take a look at 4. What would you think you would want to do first? I know what you mean. You mean to expand, right? Expand, FOIL, right? You want to, let's see if we can get all the parentheses to go away, and we're hoping that after we combine like terms and we play with properties, we can kind of move towards the right side. So this is what I'm talking about, where after you expand, you may have some, different chances to do different things, but you're keeping your right side always in mind, right? Sometimes if you're getting stuck, you're like, oh, I have no idea what to do next. Look at the right side, look at your end goal, and let that kind of guide your next step. Okay, is everybody okay with the expanded version? Okay, good. What do you guys see? Cancels. Let's see what we have left. Okay, maybe you're looking at that and saying, well, I don't think there's an identity for sine squared minus cosine squared. But this is where you want to look at your goal, right? You want to get to 1 minus cosine squared theta. So how can you let that guide your next step? So in other words, everything that I want at the end is in terms of what? Cosine, which means that I want to get rid of sine. So is there a way I can find a replacement for sine squared? Yeah, there we go. Right. But if your end goal is everything in terms of sine, then then you would make the opposite decision, right? So we're always looking at the right side to help guide our next step. What does that clean up to be? Yeah. Combine like terms, and then we have our end result. Okay, take a look at 5 a moment before I offer my steps. Okay, what do you guys decide to do first here? Okay, actually, we don't need a common denominator. Do you know why? Well, yes, you can cancel out the 1 minus cosine, but we're kind of undoing the progress that they're trying to help us make. Because if we cancel it out, then we're left with something that doesn't quite get us any closer to the goal. So this fraction is kind of helping us decide what we could do besides canceling out. Also, we don't do common denominators, and what's the reason for that? Good, multiplication, right, multiplication. If it was adding, then we definitely need common denominators, but here, so what's left? What would you do? Can we just multiply everything through? Okay, so let's just put it under 1 fraction, but just multiply everything through. And that way, we can hopefully get the denominator into something that can work towards a sign, right? Maybe an identity. Okay, so let's just multiply across. Distribute the sign through, and then expand the denominator. Actually, you know what? I should not expand the numerator. Why is that? Why should I was about to distribute the sign through. Why should I not do that?
Because the top is.
Yeah, because it's already showing, right? Because you could expand, but then if you want a 1 minus cosine at the end, and if it's already showing you 1 minus cosine, then we don't want to lose that, right? It's we're already near the end for the top, so just leave it alone, right? So again, every decision that you make, you're just always that right side is kind of helping you decide what to do. Okay, so here if I expand the denominator, the cosine goes away. I'm left with 1 minus cosine squared, and what's nice about 1 minus cosine squared? We have a clean identity there, right? Okay, so numerator stays as sine theta.
Would we just be able to do a cross cancellation for this? 'Cause that's what I did kind of.
Cross
Like I
cancellation.
simplified the sine
Theta?
to what? Yeah, sine theta into 1 minus cosine theta.
Hold on. Let me look at your paper.
Okay. And then the
So okay. So sine theta we can't convert.
oh, right, because it's
square.
not. Yeah, okay, sorry.
That's fine. Okay, so that denominator comes out to be sine squared theta. What's next? Cancel out. And I think once we do that, we're at the end, right? We have our end result once we can get one of the signs to go away. Okay, good with 5? Okay, take a look at 6. I'm realizing that the step that I did on my key may not be the most efficient, but I want to see what ideas you have. What do you guys see with number 6? That's what I did. That's what I did, and that works. There's a second option that I just realized. But yeah, I think that's the way I did it, which is good because it'll definitely work. But this solve faster. So when I see one term in the denominator and multiple terms in the numerator, what's something that I can do? Yeah, I just saw that. If I break them up into individual fractions, it's actually going to achieve a trig identity a little faster. I'll do it this way I just saw now, and then I also want to show the way that DJ mentioned, because I think getting that common denominator practice is good. So maybe we can, I think, yeah, maybe kind of write a little bit smaller so we can practice both steps, because even though, if you see a quiz problem, you can do it whichever way works, but it's just nice to get that additional practice, especially with common denominators. So the first way I saw here is, secant theta, whoops. Yeah, separate fractions here. Secant over secant just becomes, what can I do with cosine over secant? What does that clean up to be? Yep, we flip that to the numerator, we get cosine squared. So you see, it comes out really quickly to the answer. Does everybody see that? That cosine over 1 over cosine is basically cosine of theta times cosine of theta over 1, which is cosine squared theta. And we know 1 minus cosine squared theta is just cosine squared theta. But let's practice the other way. The other way is converting everything in terms of cosine. Obviously, if you could do it this way, that's great, but let's get that practice in with common denominators, okay? So everybody good with this method? Okay, so let's do everything in terms of cosine. A little bit longer, but gets that good practice in with common denominators. So everything in terms of sine and cosine. My first goal is I want to get all this down to a cleaner fraction before I move this up. So I'm going to find a common denominator here. What's the common denominator if I just want to focus on that top portion? Cosine theta. Okay, so let me write those out. Okay, we'll balance our fractions. Any changes needed here? Nope. Any changes needed here? Multiply by cosine. So I'm left with 1 minus cosine squared. We'll do some cleanup here. 1 minus cosine squared over cosine. Merge that into one fraction now that we have common denominators. And what do you know about 1 minus cosine squared here? That's sine squared. Okay, so I'm just going to save some writing here. Now that I have a clean fraction divided by another fraction, I can multiply by the reciprocal. Okay, we see the answer now, right? Cosine goes away. Okay, so seeing that possibility, that shortcut ability with number 6, can you try to applying that with 7? Look at 7 here. So 7, one option is converting everything to be in terms of cosine, but there's a different option. Do you guys split up into individual fractions? Yeah, it's a lot faster that way, right? I'm sorry, 1 over secant squared. I jumped a step here. Now that I have 2 individual fractions, I have 2 terms on the right. What happens with 1 over secant squared? Turns into cosines, right? And then secant over secant turns into what? 1. And we have our end result. Okay, take a look at 8. What are you guys thinking here? Yeah, common denominator. Yeah, there's really no way around it. Okay, so try that. Find your common denominator, balance the numerator, and see if you can push those together. Okay. What did you get for your common denominator?
1 minus cosine.
Good. Yeah, we need both, right? Those are two completely separate things. We need both to create our common denominator. Okay, spend your time balancing each fraction. Anything needed here? 1 plus cosine. Second fraction, we see we're missing a 1 minus cosine. Okay, everything under one fraction here. Any idea what we can do with this common denominator? Yeah, let's FOIL this out. It doesn't seem like we may get closer, but you know that 1 minus cosine squared can help you get to sine, and you know sine is related to cosecant, so there's that connection. What about the numerator? What can we do with the top? Yeah, just combine like terms, right? Combine like terms, cosine goes away, and then the ones becomes what? 2, okay? One minus cosine squared, turn that into sine squared. Okay, are we getting close? Yeah. Okay. Worksheet 2. Does anybody still need to look at this page? I'll leave it up for another moment. Guys, if you're working ahead on worksheet 2, skip number 5 for now. That's kind of like more of a bonus problem. So if you're working ahead, just wait till the end to do 5. Everybody okay? Worksheet 1? Okay. So give number 1 a try, and I'll follow up with the steps. So my observation with number one is, looks like both the numerator and denominator are both like something that we can apply properties for, identities for. But I prefer to work with the bottom here because it looks like the top is already one term. It just feels a little bit cleaner if I can get two terms down to one, right? I mean, I could replace secant squared in terms of tangent. I just feel like if I can get just one term over one term, things I don't want to deal with addition or subtraction getting in the way. Does that make sense? So my first thing was just to focus on that secant squared minus one. Get it down to one trig function, and then it's a lot easier to work with a single term rather than addition and subtraction. Okay, so what can I do with secant squared minus one? Tangent squared. Okay, so if you can take that first step, I think this becomes a lot more straightforward. It's just like, well, get everything in terms of sine and cosine, and then the purpose is, I guess purpose not really to make it match the right side. We just know that things are easier to match and cancel out if everything's in terms of, you know, rather than like secant and tangent, right? Okay, multiply by the reciprocal. Okay, we're there, right? 1 over sine squared becomes cosecant squared. Okay, good. Number 2, what are you guys thinking? Yeah, common denominators. Yeah, let's get those common denominators. We can push the numerators together, and we're hoping that as we balance the numerators, things will become more clear. Maybe some identities can be applied, and then we can start working. It's a lot easier to match parts if we have just a single fraction. Okay. Yeah, go ahead and see how far you can get with this one.
I did number one at different times. I'm not sure.
Yeah, I'll look at it.
Like, I divided the secant squared on this side by.
You can subtract it. If you divide it, then there's still a 1 on the right side.
Yeah, well, that's
Okay.
that's why I'm not.
Got it. That's equal to 1.
Not sure.
So we divided
Yeah.
squared, but I
By
still don't
10.
see.
So if I
Okay.
added this by 10, that's what that is. And then that's simplifies to squared.
Oh, okay, yeah, that works.
Okay.
You went from here to here.
Yeah,
and then-
sorry, that was confusing.
No,
but
it works.
It was okay.
One plus two. 1 plus 1. Yes. 1 plus cosine squared plus sine squared. But this needs more power. So we need 4 plus 1 plus cosine squared.
I don't know.
1 plus cosine squared. You have 4 around. I'll show you.
Oh,
You have 4 around. Okay, number 2, common denominator here. Okay, we'll balance the numerator. First numerator, what's missing? 1 plus cosine x. Second denominator, what's missing? Sine x. So I have to spend the time to FOIL all this out. We can't just say 1 plus cosine squared. So it's going to be 1 plus cosine x plus cosine x plus cosine squared. And this becomes sine squared. Okay, it's a lot of messiness here, but I'm going to try to push all the numerator terms together. I'm going to combine some like terms. Cosine plus cosine becomes 2 cosine. All right, what do you see here? Numerator, anything?
cosine squared.
Okay, what else? What is the numerator clean up to be then?
2.
Mhm. Good, good. GCF. GCF is shared between the 2 and the 2 cosine x. Factor a 2 out, and we're left with what? 1 plus cosine x. All right, so everybody seeing how I factor out the 2 and I'm left with 1 plus cosine x inside? Okay. Good, so now it's a lot more clear, right? Get the 1 plus cosine x's to go away. And now we're at the end, right? We know sine and cosecant are reciprocals. We flip that sine up to be cosecant. There we have it. Okay, take a look at 3. What are you thinking about 3? That's an option. I think I see a better option though. Yeah. Okay.
Oh, the identity.
Yeah, let's do the identities first, right? I mean, you could follow it out, but I don't know if it's gonna. I mean, it works. It's a longer path. Okay. What can I replace 1 plus? Oh, sorry, cotangent squared plus 1 with? Secant squared. Sine squared minus 1. Careful. Yeah, sine squared minus 1 means that the cosine squared has to be on the other side. It's going to be a negative cosine squared. All right, so now it's a lot easier, right? What if I just get everything in terms of sine and cosine and see what happens? Is that the same as our right side? Yeah. Number 4. Does that numerator remind you of anything? What if I gave you a hint? X squared minus 2x plus 1. Yeah, factoring. Yeah, we got to treat this like we do a trinomial. So why don't we do this? Why don't we just factor this problem, and then we can replace the x's back in terms of sign. What's the factored form of x squared minus 2x plus 1?
2 times x.
Okay, close. Yeah, we want to multiply to be 1 and add it to be negative 2. So we're going to have a x minus 1 and x minus 1. Okay. Okay, we're pretty good here. And now I can just replace the x's with what? Sine. Okay. Well, the sine squared will break down into sine and sine. So we just have sine theta. Oh, okay, I see what you're saying. Sine theta minus 1 squared. I'm going to keep them separated, but yeah, you can put them together if you want. Does everybody see? Are you guys okay with the jump from here to here? Okay. Cancel out. Okay, back page. Let's skip number 5 and go to number 6. Okay, does anybody still need to look at 4? Okay. Okay, 6 should feel easy, right? What did you guys do first?
I agree.
Yep. I mean, I can distribute through, but I mean, that's set up so nice for me to apply an identity. What does 1 plus cotangent squared become? If you know that this is equal to 1, that's fine, or you can make it 1 over sine squared. 7 is a duplicate from previous, but see if you remember the steps for 7. What can we do with 7? Yeah, break it up. Right. Yeah, we saw that before. I mean, we can convert everything in terms of cosine, but okay, last one, number 8. What are you guys thinking? Yeah, that's what I would do. Maybe some of you are thinking maybe common denominators, but if you look at the right side is 2 separate terms. So I don't know if common denominator is really going to help us get there, but if we can get everything in terms of sine and cosine, maybe each fraction will turn into one of the trig functions that's showing up on the right side. So yeah, let's get everything in terms of sine and cosine here. Okay, let's flip those fractions up. Cosines cancels out. Sines cancel out. So we're there, right? Yep. Yeah, let's leave 5 alone. You won't see one that hard. I think if I can just come around and just check you guys off, just show me worksheets 1 and 2. I'll have a help session tomorrow. I'll create a worksheet 3. I'll try to post it on the website this afternoon in case you want to work it through on your own and check with the key. Okay. Okay, just have it out. I'll be over in a second.